three states of matter: solid, liquid, and gas. Any substance can go from one state of matter to another state of matter by changing temperature or pressure or both. These are physical changes, not chemical changes. Remember, all of these particles are moving. They have kinetic energy, which is the energy of movement. Solids have the least kinetic energy, liquids have more, and gases have the most. So to change the phase, you can alter the pressure or temperature to get the desired state of matter. To go from a solid to a liquid, you add energy to melt it. But to go from a liquid to a solid, you'd want to remove kinetic energy by decreasing the temperature, and that's freezing. Similarly, a gas can become a liquid by lowering its temperature and condensing. When a liquid's temperature increases enough, it can vaporize to become a gas. Let's take a moment here to talk about vaporization so we can clarify a few things. Under the umbrella of the term vaporization are two ways to get liquids into gases. The first type is evaporation, which occurs at the surface of a liquid that is not boiling. This is like when you spill a drop or two of water on the table and leave it there. After a while, the water is gone, but you didn't have a blowtorch on it to heat it up. The surface particles have enough energy to escape the liquid and become vapor until eventually the whole drop of water becomes vapor. Boiling is the rapid vaporization of liquid at the boiling point. In this case, you would either add heat or lower the external pressure on a liquid to get to the boiling point very quickly. Both methods make vapor, but boiling is much faster. Now back to the phase changes. Now solids can also skip the liquid phase and go directly to gas under the right conditions, usually low pressure or temperature. It's called sublimation. This is how we freeze-dry food and why dry ice, which is solid carbon dioxide, makes great spooky fog at Halloween. Gas can also go directly to solid in a process called deposition, which is also sometimes called desublimation. The way I've organized the states of matter makes for a pretty chart, but doesn't do the greatest job of showing how adding energy makes a difference, so I'm going to adjust them slightly. Now these are in the order of increasing energy. Just remember that sublimation and deposition skip the liquid phase. Now I could also be more specific when I write increasing energy. I could say increasing kinetic energy. Kinetic energy is the energy of movement. Particles are always moving. Particles of a solid move less than particles of a liquid, and particles of a gas move the fastest. But not every particle is moving at the same speed. Some are moving a little slower, and some a little faster. But the average kinetic energy of a group of particles is temperature. This bell curve shows the kinetic energy for particles in a sample of matter, and the average energy of the particles is temperature, which we measure in Celsius. The temperature at which a solid becomes a liquid is the melting point. Using a chart like this, you can figure out what temperature you need to get a solid, liquid, or gas phase of the substance you're using. For example, if you're performing a lab that requires liquid oxygen, you need a temperature between the melting point and boiling point, which is where the liquids exist. So the oxygen will have to be cooled to at least negative 183 degrees Celsius, but not as cold as negative 218 degrees Celsius. A container of liquid nitrogen could help us get to those temperatures. Now suppose you want to use bromine in its vapor form. You would need to heat it past its boiling point. Gas or vapor phases are all above the boiling point temperature. Bromine is a liquid at room temperature, so it only needs a little more heat to get it to vaporize. Now let's say you found some mercury and wanted to make it solid. You would have to cool it down to at least negative 39 degrees Celsius, its melting point, to get solid mercury. At room temperature, which is around 23 degrees Celsius, everything that boils below 23 degrees is a gas, so that's neon, oxygen, and chlorine for this chart. Anything where 23 degrees is between the melting and boiling point is a liquid at room temperature, so that's ethanol, mercury, bromine, and water. And lastly, anything that has a melting point higher than room temperature is a solid at room temperature, like sulfur, gold, and copper. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.